Today we're going to look at how to find the surface area of right pyramids and right cones. Now, a right pyramid and a right cone ultimately means that you have a 90-degree angle, like so, between the what's referred to as the apex and the center of the base. So this area down here is called the base. Because it makes a 90-degree angle, that refers to it being a right pyramid or a right cone. Now, as you can see, we always have a base shape. In the case of a cone, we have a circle. In this case of this pyramid, it looks kind of like we have a square base or maybe a rectangular based pyramid. Now, there is something also that we need to refer to, some terminology here. This here is your slant length. Same thing here. I go down this face so I can create a little right angle triangle in here. This distance here is your slant height. And same thing here. So there's two different types of height. You have your perpendicular height, the one that makes it a right triangle or right pyramid or a right cone. This is called your perpendicular height. And that's the same thing here. That's your perpendicular height. So you need to know where your apex is, which is the point of the top of both the pyramid and the cone. You need to know what your base shape is, so in this case a circle and a rectangle or square. You need to know what your slant height is, which is those ones here, as well as your perpendicular height. Now in the case of a circle, we also need to know this distance here, which is your radius. Now some of the other things that you're going to need in this unit, you need to know Pythagorean theorem. So a squared plus b squared equals c squared. Because these create right angle triangles in both of these two three-dimensional shapes, this is going to come into play where our perpendicular height could be our a, our b could be our radius, and our c would be our slant length. Same thing here. A could be your perpendicular height, b could be your base, and c could be your slant height. So there are right angle triangles, and you have to use Pythagorean theorem throughout this. Now that we've talked about what terminology you need to know for your cones and for your pyramids, we're going to look at what surface area is. And basically it's the sum of the areas of each face. Another way to look at it is the sum of the lateral area and the base area. Now if you look at a cone, like below, this is your base area. Which is the area of a circle. So we know the area of a circle is pi r squared. And up above, the part that wraps around, that is referred to as your lateral area. Now, in the instance of a cone, we actually have a formula for this, and it's based on your slant length. So again, that distance here, the slant length, it's referred to as pi r s. S is going to be your slant length. So the total surface area, we add together the pi r squared for the area of the base and the pi r s, which is your lateral area of the actual cone. So if we look at this particular example here, we can see that it has a perpendicular height of 4, a radius of 3, and what we require for this surface area formula is pi times your radius squared, so 3 squared, plus pi times your radius times your slant length. Now we don't have that as of yet, so we have to use Pythagoras. So a squared plus b squared equals c squared. A is going to be your perpendicular height, 3 is going to be your radius, and it works out to c squared. Now this one is a Pythagorean triple, so I know that if I work this out, 16 plus 9 is going to equal my c squared. 25 equals c squared. If I square root both sides to get just c by itself, you get c. So as a result, once I've figured out my slant length, that actually equals my s in my equation. So then we can do our surface area. It's going to be 9 pi, because it's 3 squared, plus pi times 3 times 5. Surface area is then going to become 9 pi plus 15 pi. Now, there's two ways of leaving your answer. You can either leave it in terms of pi, or you can leave it as a decimal approximation. So 9 pi plus 15 pi is going to give us 24 pi's, and we'll just say units squared because it's a surface area. Now, if you multiply 24 times pi, that will give you your decimal approximation. So as a result, you'll get, when you times 24 times pi, you get 75.398, well, 3 decimal places, units squared. Okay. So these are both appropriate answers. One is left in terms of pi and one is a decimal approximation. So this one is an approximation, that one is exact because it's in terms of pi. So now we're going to look at how to get the surface area of a pyramid. In this case, it's a square base pyramid. And we can see that the area of the base is going to be 8 times 8. Now the lateral area is the area of all the other faces, excluding the base. So when we have the surface area of this square base pyramid, we know that's going to be 8 times 8 for the area of the base, plus, and we have to consider all the triangles that we have here. Now, given that this is a right pyramid, and that it's square base, they all have the same base of 8. What we need to figure out is then how to add them all together. So since they're all the same, we can actually say 4 times, it's going to be area of a triangle is half your base times your perpendicular height. So half times 8, which is your base of your triangle. Your perpendicular height is given to you, so you multiply it by 10. So there's 4 identical triangles. And then the area of a triangle is half base times your perpendicular height. So that's where this formula comes from. So we know that our area of our base is going to be 64, and if you go 4 times a half is 2, 2 times 8 is 16, and then multiply by 10, so you get 160. So if you have 160 and you add your 64, your area of your surface area is 224 units squared. And you can leave it like that for your area. And in this case, actually, sorry, those should be centimeters squared because they give you units.